geobyte.
Similarly, let us take the another important problem. Okay, look at the screen. It is asking like this. A nucleus disintegrates into two nuclear parts in such a way that ratio of their nuclear sizes is 1 is to 2 power 1 by 3. That means d1 by d2, right? Assume it is disintegrating into nucleus is disintegrating into two parts like this. Let the nucleus disintegrating into two parts. This is the first part and this is the second part. This part is moving in this direction with a velocity v1. The other one is moving in this direction with a velocity v2. The ratio of their sizes d1 by d2 equal to r1 by r2 is equal to 1 by 2 power 1 by 3. That is given. Their respective speeds have a ratio of n is to 1, then the value of n is. You are asked to decide what is the value of n. For that, let us connect the law of conservation of momentum principle. Applying law of conservation of momentum. You know, here m1 v1 must be equal to m2 v2, but density rho equal to mass by volume. From this mass equal to density multiplied by volume, then it can be written as rho 1 into volume of the first part multiplied by v1 is the velocity of the first part. Similarly, rho 2 into volume of the second part into v2 is the velocity of the second part. But density remains same. Rho 1 equal to rho 2. Volume of the sphere. Each nucleus that is looking like a sphere. Volume of the sphere is 4 by third pi into r1 cube into v1 equal to 4 by third pi r2 cube into v2. Here 4 by third pi, 4 by third pi cancelled. Finally, it is r1 cube into v1 equal to r2 cube into v2. From this, I can write that v1 by v2 equal to r2 by r1 whole power 3. But r1 by r2 given. Since r1 by r2 is 1 by 2 power 1 by 3, I can write r2 by r1 equal to 2 power 1 by 3 divided by 1. So it is equal to 2 power 1 by 3 by 1 whole power 3. Therefore, v1 by v2 is equal to 2 by 1, or v1 is to v2 is equal to 2. That is the answer. 2 is to 1. That is the answer. Understood clearly? Yes. So here n value is, right? It is given n is to 1. N value is 2. Okay. Similarly, let us take the another important problem. Look at the problem. An average force of 125 newtons is applied on a machine gun firing bullets, each of mass 10 grams, at the speed of 250 meter per second to keep it in position. The force acts on the or force applied on the machine gun equal to 125 newtons. Then bullets are releasing. Mass of the each bullet is 10 grams, that is 10 by 1000 kilograms. Each bullet is releasing with a speed u equal to 250 meter per second. The number of bullets fired per second by the machine gun is, how many number of bullets are, right? Let n equal to number of bullets released bullets released per second, right? That n value you're asked to decide. For that, as you know, this force must be equal to, right, mass into velocity for one bullet multiplied by number of bullets. Number of bullets equal to force by mu. Force is 125 divided by mass 10 by 1000 into 10 by 1000 into 250. 250. It is equal to 125 into 1000 divided by 10 into 250. It is 125 into 2. Finally, it is equal to 1000 by 20. 1 0 cancel. 100 by 2 is equal to 50. These many bullets are releasing in 1 second. 50 bullets can be releasing from the gun, machine gun, in 1 second. Okay, understood clearly? Yes. Similarly, let us take the another important problem. Look at this problem. A particle of mass m moving with a velocity v collides with a stationary particle of mass 2m. Let us take a particle of mass m. It is traveling with a velocity v. It is colliding. A big particle is maintaining 2 times the mass. This particle is fixed, means stationary. Stationary. This kind of collision is called what? Elastic collision. Elastic collision. Okay. After collision, they stick together and continue to move together with velocity. After this particle is colliding the stationary mass, both are moving with the same velocity. What is that velocity? Very simple. Here, right, applying the law of conservation of momentum. Law of conservation of momentum. M into V plus 2m into, it is maintaining the velocity V equal to 0. Let that is V dash. So 2m into V dash is equal to m plus 2m into final velocity V2. This V dash is 0. mv equal to mv equal to 3m into V2. This m is cancelled. V equal to 3v2. Therefore, final velocity of the combined system equal to v by 3. Look at the option A. Option A is absolutely correct. Are you following clearly? Yes. Similarly, look at the another important problem. Figure A, B, C and D shows variation of force with time. Look at the figure A, figure B, this is the figure B, figure C, and figure D. Okay. Then what you're asked to decide, the impulse is highest in figure. You're asked to decide which figure is maintaining the highest impulse. As you know, impulse equal to what? Impulse equal to, right? Impulse equal to, since impulse equal to force multiplied by time, it is equal to area of, right, force versus time graph. Force versus time graph. Then the impulse for the A equal to, it is looking like a triangle, half into base is 1 into height is 0.5. It is 0.5 into 0.5, 0.25. Newton second. That is the impulse for the A. Similarly, impulse for the B equal, it is looking like a rectangle. Breadth multiplied by depth 2 into 0.5. It is equal to 1 Newton second. Similarly, impulse for the C, it is also looking like triangle, half into base into height 0.75. It is 0.75 by 2.375 Newton second. Now this is also looking like a triangle. The impulse for the D equal to half into base into height is 0.5. It is 0.5 Newton second. Now for the first figure, impulse is 0.25. Second figure, 1. Third figure, 0.375. Fourth figure, right, zero point 0.5. Among all these, the figure B is maintaining the highest impulse. Now look at the options. Figure B is maintaining the highest impulse. Therefore, option B is absolutely correct. Understood clearly? I am trying to explain the each and every point at your understanding level. Okay. Similarly, look at the another important problem. Try to read it clearly. It is given like this. A ball is dropped from a height of 20 meters. If the coefficient of restitution for the collision between the ball and floor is 0.5, after hitting the floor, the ball rebounds to a height of. The initial height of the ball is 20 meters. Coefficient of restitution is given 0.5. Rebouncing height, that is h dash, is how much? As you know, the rebouncing height h dash equal to coefficient of restitution power 2 multiplied by initial height of the ball. Coefficient of restitution is given 0.5 power 2 into h value 20. 20. It is given 0.5. 0.5 I can write as 5 by 10. 5 by 10 whole square into 20. Now you can simplify it. Is 25 into 20 divided by 100. Right? 10 square is 100. It is 500. 25 into 20, 500 divided by 100 is equal to 5. So the rebouncing height of the ball is 5 meters. Understood clearly? Yes.
Geobyte.